Today is January the 6th, 2021. And I know I've made one video of this modulator, but this is such a project. This one deserves more than one video. Lots of things have happened with it. Not all good. Although the amplifier is working great. It's an amplifier. It's an audio amplifier. Instead of having an 8 ohm output, it has an 8,000 ohm output. That's all a modulator is. Now this is just a power amplifier. I drive it with 8 ohms. Right here. Out of this Macintosh amplifier right now. I get 20 dB gain out of it, as a matter of fact. So it's really easy to drive, and that has caused me some problems that I wasn't aware of at the time. I used to have 2 meters hanging up here like this. Well, here I'm here to tell you something. These things, this one measures up to 5,000 volts AC and DC, and the other one measures 6,000. But that is not 6,000 volts at a kilohertz. And besides that, I think I was overdriving it, so I don't know how much voltage I was putting on it. Even though it says it's good to 6,000 volts AC, and I actually know that it is, but it's talking about 60 hertz. It's not talking about audio frequencies of a kilohertz. This thing will pump an enormous amount of power out. I guess you can see where I just let it lay there and it burned. That's how much power I could put into this 200 and whatever this thing is, 225 watt resistor. I'll put it up on some heat sinks. But the way I've safely figured out how to measure it is by measuring the current. I got these beautiful little Tektronix clamp-on ammeters. So I just click that around there and I measure the current. Of course, it gives me peak to peak. I've got to convert that to RMS, but it comes out exactly right. I verified that by measuring the current out of here, just straight into 8 ohms, and comparing it to the meter up here. I know I've got everything turned off at the moment. I'll turn it on and I'll wrestle this thing over on its side and tell you what's going on. Now, I was using a 6X5. I'm still using a 6X5 right here. But I was running it, I was making a bridge out of it. I was using this for half of it and then 2 diodes for the other half of the bridge. And the 2 diodes shorted. And at the time, I only had 1 fuse in this thing, and it was a 20 amp. Well, I don't know if you remember the last view of this amplifier, but it had a different power transformer back here. I smoked my power transformer. It made me feel really stupid. That little transformer was just perfect. It had everything. It had 2 primary windings, which I used the second primary winding because I didn't need to run it at 240. I used it as the bias supply. And it has a 6 volt and a 5 volt winding for the 2 rectifier tubes. So it did a really good job, but I was careless. Of course, I put a fuse in now. I think it's a 1.5 amp fuse. I don't know if y'all can show it to you or not, but it's right back here now. Right there. Yeah, right there. That just fuses this one transformer. Yeah, dumb things happen. And like I say, putting the high voltage of a kilohertz across my other triplet meter, I think I've ruined it permanently. It turned 2 resistors into such carbon that it almost set a piece of paper on fire that was in, here it is right here, that was inside. This is the schematic. This is the part of the manual for that meter. And I had it folded up in there. You can see where it's charred here on the sides right there. So it almost caught this piece of paper on fire in there. But this is the one I ruined, it looks like. I probably had something arc over in one of the wafer switches that I haven't found yet. I haven't given up on it, though. I use a 8 ohm to 8,000 ohm transformer to take the 8 ohms here and convert it to 8K, and then I drive the grids of these. And I also realized, I said, well, you know, maybe I could use that same transformer because the turns ratio is the square root of that ratio, 8 to 8,000, the square root of 1,000, 30 something, and turn 6 volts into whatever that turns into, 300 something, and it works. I put 6 volts into the 8 ohm winding of the transformer and monitored the current with a different type of clamp on ammeter, and it was measuring about 400 milliamps. So I said, well, that's pretty safe. So I just let it sit there for a long time, for a couple of hours, watching it closely, and it never got hot. So I said, this is okay. So then I put the secondary of that, which has a center tap, into that 6X5 over there, this little 6X5. So I don't have to have a bridge anymore, and it works beautifully. I just never thought about using a audio transformer as a power transformer, but that's my bias transformer now, since I don't have the extra winding on this big guy back here. I'll show you underneath it in just a second. It's beautiful. Turned out really nice. Of course, by adding that big gray transformer and another one underneath, I just made it that much heavier. The thing is just absurdly heavy, and I'll have to get somebody to take it to the basement and help me install it. I just hope that it's not like a 1/8 of an inch too tall. I've measured it pretty carefully, and I think it's going to fit. But we shall see. I just wanted to share some of the uh-ohs that you got to be careful with. Be very careful when you start trying to measure audio frequencies on your voltometer. This is not the first meter I've fried. I've fried some Tektronix and Fluke meters too, sadly. By the way, this little meter right here that I got at an estate sale, it's a Fluke. That is a jewel of a jewel right there. First of all, it measures some pretty high voltage. I know there's terrible glare on it, but it measures AC and DC at the same time. And I just realized the other day how, even though I'm measuring the DC voltage, which is that second one down there, the AC voltage up there is it's telling me if there's any ripple on it. That is a beautiful little meter right there. So if you ever can find one at an estate sale, that's reasonable. And around here, everything's pretty reasonable. I just went to one the other day, and they gave me a whole bunch of stuff free just to get rid of it. So that is that at the moment. Here's the audio to set it up. Microphone, I'll drive it. I'll show you how this thing drives. I'll show you underneath it. Show you the voltages and all that kind of stuff. But I just wanted to get started and mention some of the things I wish I had done and not have done. Okay. Now that we're all set up, everything's nice and warmed up, let's take this a step further. I'm going to put the high voltage on. I do that by grounding this point. This is that relay picking up is actually not dropping out. I have a holding relay system down here in this thing that I've had for over 45 years in that box. I built that when I still worked in Huntsville in the metal shop one night, probably on midnight shift when I should have been doing something else. Anyway, it's got a great big isolation transformer in it, and anytime that there's a kind of a heavy load on it, if it's not enough to actually blow a fuse, it'll try to make that it lowers the voltage just enough that relay in it is so large it tries to drop out, but it doesn't. It's really interesting how that thing works. It certainly wasn't a factor in me designing it. Now I'm going to show you something here about bias that you might find interesting. First of all, there's high voltage on there. I got to be careful. There's 2600 volts on the plates of those tubes. And as you can see, they're not turning orange hardly at all. And that's because I have the bias actually quite negative. I don't know what it is right now. I was thinking about putting some test points in there so I could monitor the screen and bias voltage, but it's quite stable. Anyway, so let's drive it and I'll show you. Oh yeah, and the way that I'm measuring it is with this current probe. See, it's just clamped around the wire. That's all it is. And if you want to make it twice as sensitive, you wrap it around there twice. If you want it to measure 3 times, you wrap it around there 3 times, just like you can any current meter. Really interesting. And I've also put it up on this heat sink so that it'll burn my tabletop again. Not that it's like fine china or anything, but see, it's 83 degrees right now. We'll see what it is in a minute. Yeah, I can just barely detect a little bit of orange in there. Okay. So we're going to be measuring the current here. There it is coming up. And it's set on 10 milliamps per millivolt, as you can see right there if I get my head out of the way, the shadow. and we got this set at 10 millivolts. So that's 100 millivolts, 100 milliamps per division, and we turn it up to where we get some distortion, not too much. And if you look that over carefully, that's about 42, well, it'd be 420 milliamps. There's a little bit of distortion there, but remember, we're not trying to make a big stereo amplifier, 20 to 20 kilohertz at 0.5%. And there's the power driving it. It takes 4.89 watts to drive it with the bias setting I have on it right now. And you can see that they've turned a little bit orange. Well, if we take this 420, let's turn it back down. If we take this 420 milliamps, remember that's peak to peak. So we have to convert that. I don't know if you'll be able to see this or not because of the shadows, and I'm not sure all this is terribly important, but I do want you to see that's 420, so that's, excuse me, that's 0.42 amps. And we have to divide that by 2 times the square root of 2, which is approximately 2.828. And then it's I squared R. Then we square that, and it's into 10,000 ohms. See, it's 220.57 watts. I think you can see that. 220 watts with the 4 point whatever it was. Remember the power that we were reading here? Now, with it on and everything, I'm going to get out a screwdriver here, and I'm going to lower the bias. This is something that probably should interest everybody. I don't know if I'll be able to hold this as steady as I want, because I got to get back here and get into the bias pot. I think I'm going to have to stop the camera and adjust it just to be safe. Okay, I think you can see that they are a bit more red, orange. This color actually, this camera actually tells you the real color of them. Okay, so I've made the bias less negative, so I've got more plate current flowing. Now watch what happens when we drive it. We'll drive it to the same 420 milliamps. And see the amount of power we require now. 2.7 watts. And that's how orange they are. So if you make the bias less negative, it has less voltage to overcome. You can drive it a little bit harder with just a little bit of power. And when you get it down, I can make them a little bit more orange, make the plate current a little bit higher, and drive it with as little as about 2 watts. Then I get quite a bit of gain out of it. I can turn 2 watts into 200. That's 20 dB. So there you go. That's what it looks like running, and that's the way I'm measuring it. Like I say, this power right here that we were looking at is the power coming out of this amplifier, driving this amplifier. So let's turn the high voltage off of it by removing, just got a solid state relay in there so you don't hear anything click. And I'll let it cool down for a few minutes. I'll flip it up on its side, and we'll take a look underneath, see if I can get it all the way upside down. While we're waiting for it to cool off, I'll show you the temperature of that resistor now. Remember, it went from like 80 degrees to whatever, 280, it's above boiling. It hasn't transferred much heat into the heat sink, but the resistor itself, so you can tell it's pumping a lot of power into it. Okay, let's take a look underneath it. Where the beauty really lies, in my opinion. See, here's the 8 ohm load resistor for the input. Remember, I think it's a 20 watt, but we're only going to be putting, 3, 4, 5 watts into it at a time. This is the screen all strapped together right here. Got a resistor off the ground. Here's where the screen feeds it. If it's an RF tube, you really have to go through this. For audio, you don't have to go too much through this, but you do want to keep any RF out of the amplifier. So I strapped the filaments together, and then I put one off the ground right here. This is the filament transformer. This is the high voltage right here. These are 100 microfarads in series. These are 330. The value of these are not terribly important. This relay right here is one of the three things that I use the bias for. It's a 10,000 ohm DC coil, and I've got a resistor in series with it right here. It's in series with the coil lead, so that it just barely picks up. Only when the voltage is always the bias voltage is up at 100 volts or more will it pick up. Now adjust the bias right here. That's what I'm setting it. See, I've got it set almost all the way up. Right there is all the way up. So the bias voltage has to be up before I can apply screen voltage. So the screen voltage is actually going through this relay. And then when I turn the power off, this relay, when it drops out, which would be its normally closed contact, when the relay is relaxed, it grounds the screen voltage through this resistor right here. So it drains it pretty quick. This is a solid state relay. Doesn't make a sound. It runs off of, I can see it here. I don't know if you can read it. It runs off of 3 to 32 volts DC. So I'm running that off of the bias voltage. Here is the bridge. A stack of diodes, 10 on each side, so each side of the bridge is 10,000 volts. Here's the high voltage side over here. I've thought about putting some, I like to use those fractional ohm resistors, like a 0.47 and 0.33. All that value isn't really important. They're little 1 watt resistors. I've been thinking about putting one from here to there and here to there. They act like fuses, and if you short the high voltage, they explode. And they've saved me more than one time. Here is the RCA jack. That's this right here grounds the other side of this and turns the high voltage on. Here's the output. See all these, this is meter lead wire right here coming from the modulation transformer. So it's got the, I guess the plate, the center tap, and I think that's the secondary, I'm not sure. This is the driver transformer. These two transformers are really the same. I think they come out of slightly different units, but they're both 8 ohms to 8K. So that's impedance ratio of 1001. So you take the square root of that and you get its turns ratio, or its voltage ratio. And this one's actually driving it. See, there's the 8 ohms in, and down here it's connected to the grid. I always put a resistor of some value, maybe 2 or 3 times. Seems like that's what everybody does. 2 or 3 times the impedance from the center tap to one side, because you want the transformer to have some real resistance to work into. Up here's the bias rectifier, and here's part of the divider network for getting my voltages to run this thing and to actuate that. Screen supply. Use a couple of big capacitors up here, 800 volt, 25 microfarad. I just goop them to the side. Here's the bias choke. I like chokes. I got a bias, a pi filter in the bias supply. Same thing in the screen supply. And of course this big guy on the top is for the plate. And again, here's the bias. And here is that, I did put in a fuse right there that supplies this transformer right here, which is the bias and screen, because this one down here is a 20 ampere and it wouldn't blow, and that's why I melted my other transformer up there. You can see the holes where it used to be mounted. But you got to do what you got to do sometimes. So there it is underneath. It's actually quite simple, isn't it? But this kind of stuff is, I guess it keeps me sane. I'm not real sure. I can't turn it around with one hand, but I'll show you the back of it. I used, well, maybe I can. Maybe I can kind of scoot it around a little bit. I'd like to show you how I, there you go. How I use that brother type of labeling system. Put 2.5 up there, turn clockwise to increase current. High voltage to the class C alpha. You're on the high voltage end. The side goes to the plate. 15 ampere here. I changed it from 20 to 15. It says ground for 2600 volts AC, of course, and ground, which I never build amplifiers without, so I can hard wire all of the chassis together so they could never become electrically separated. So there you go. I think that's it. I'll probably have to make another one and compare it. I hope I can do that before I disassemble the other one and compare it, the audio of the way I'm driving it now with that Mac amp turned around with a big transformer, and how this one measures different from it. Well, anyway, thanks for watching. Stay safe. I hope that some of these things that I've done wrong, I don't mind sharing with you. I don't mind telling you all the stupid things that happen. Maybe it'll keep you from having stupid things happen. When that transformer up here, when I shorted it, there were two little diodes across here. They're what shorted. That's what started it, and it melted that transformer down. And the current was so high it even shorted my AC on/off switch. Crazy, huh? Stay safe, and we'll hopefully make another video and see you again soon. Thanks. I don't know if you were paying real close attention, but these are the two tubes I just had in it. One is labeled GE and the other is labeled RCA, and they apparently are working perfectly, but I put the two Eimacs back in there this time right down. I've only got 5 tubes, so I never like to build anything with just a minimum amount. I got one more that I don't think works very well. It draws a lot of extra filament current, so I think filament may be partially shorted. But I just thought I'd show you. Don't you think that all of these right here, don't you think Eimac made them all? I mean, I can't tell a hair's worth of difference. Well, this one right here doesn't have this rib in it. This one right here, maybe RCA did actually make that one. See, these have the rib right there, and right there, and right there. Just hard to imagine that they wouldn't buy these from one another. One last thing. You know I do this all the time. Look at this little relay I have. Isn't it the cutest little thing? It's a high voltage relay. It's 12 volts, as you can see right there. 12 volts DC. And it's a single pole double throw. You know, right here is the movable contact. If you look in it really close, you could see. I'm just thinking, but is there any way I can put this thing in there to protect the amplifier? I mean, obviously the human protection comes first, but you also have to protect your tubes. You never want to apply screen and plate voltage without bias. So that's why I have it set up the way I do. I cannot energize the solid state relay without the bias voltage. I cannot even put screen voltage on the tubes without the bias voltage being up. So I'm wondering if you can think of how I can put this in the plate lead somewhere, because it's a high voltage vacuum switch, to protect the amplifier. It's not a human safety factor, it's an amplifier safety factor. If you can think where I might put that and how I might get the 12 volts to it DC. I don't know how much current it draws, probably not too much. I don't know if I should run that off the bias or not, you know, with a voltage divider, get it down to 12 volts. What do you think? What would you do if you had this pretty little thing?